Up to now we used bit as type of our signals. This type only offers two states, 0 and 1. But how can we model larger and more complex signals in VHDL? Hello everyone and welcome to our overview of different types VHDL offers. Digital circuits are based on binary values. Therefore, we basically just need to distinguish between two states, 0 and 1. With these two values, arithmetical and logical functions can be implemented. However, having only two states has some disadvantages. Imagine you have designed some digital circuit in VHDL and not initialized some signals at startup. In this case, we do not know which state a signal currently has because it depends on the actual implementation of the circuit on the chip. Consequently, not only the state of the signal is unknown, but so are all the values that are derived from it. To cope with this, VHDL offers signal types that include special states for debugging purposes. Some of them are based on the 9-valued logic. As the name already suggests, this logic distinguishes between 9 different states, as you can see here. In this video, I want to focus on the two most important values, U and X. The U is assigned to signals which have not been initialized. This occurs if no value is assigned to the signal at the start of the simulation. X means an unknown logic value due to invalid situations such as two processes assigning a value to the same signal. On the left side, you can see a simple example of a digital circuit with two inputs, A and B, an AND gate, and the corresponding truth table. Uninitialized signal values are always dominant, except for if one signal is 0. Unknown logic value and 1 as input signal results in X as output value of the AND gate. Now we know that there is the 9-valued logic in VHDL, but which signal types are based on this? The answer is STD logic. This will be one of the main types we use in this tutorial. Additionally, if you want to model multi-bit signals such as a bus, VHDL offers a signal type called STD logic vector. Let's move on to a simple example. Here you can see the empty architecture description I already prepared to show you how to use STD logic and STD logic vector. Let's start with the former. In this case, there is no difference to the type bit. As you can see, instantiation and assignment work the same way. For STD logic vector, we additionally have to define the size of the vector. In this case, let's just choose 8 bits. Usually, the declaration starts with the most significant bit, the MSB. And since the array index starts at 0, we declare the size of the vector using 7 down to 0. The signal assignment can be done similarly to STD logic and bit. Additionally, STD logic vector also allows to only consider a subset of the vector. As an example, we can only consider the 4 MSBs in our logical function. Okay, cool. Now it's clear how to model signals using 9-valued logic. But sometimes we do not want to model binary signals but integer values. For example, if you want to implement a simple arithmetical function, it would be easier to just use integer values instead of a binary vector. Therefore, VHDL offers several additional types. Integer, signed and unsigned are only the most relevant ones. Let's have a look how we can use them in our model. The initialization again is similarly done for integer, except that we can define a valid range for the values. Now that we have defined two integer signals, we can implement a multiplication operation in a single line of code. As we have now used several different types, it will only sometimes be possible to use just one of them. Hence, it is very common to convert the signal type to use the values of a signal for some logical or arithmetical operation. VHDL offers several functions for type conversion, as shown in the picture right next to me. Let's quickly summarize. VHDL offers several types to model larger and more complex signals. In contrast to just using the type bit, these offer better debugging properties by making use of additional logic values such as u and x. In addition, if we want to model arithmetical operations, integer, signed and unsigned are the types to go for.